Hello everyone, Satyajit Pattnaik here and welcome back to my channel. You're watching the Deep Learning playlist and today's topic is all about backpropagation in neural networks. In the previous video, you learned about how forward pass works in the neural networks. Today's video is all about backpropagation with an example. I'll be trying to showcase you an example as well so that you have a better understanding on how neural networks work, how the weights work and all those things. So let's get started. Now, before moving ahead, just giving you a brief introduction about forward pass so that we understand the concepts. So let's say I define my hidden layers, input layers and my output layer, something like this. So this is my input layer, this is my hidden layer, and this is my output layer. So all the neurons are connected with each other, something like this. So this is my X1, this is my X2. And we already know that each connection has weight assigned with each other, right? So we have W1, W2, W3, W4, and it goes on W5 and W6, W7 and W8, something like this. I'll name the hidden layers as H1 and H2. And we already have two inputs, X1 and X2, and I will name the output as Y1 and Y2. So theoretically, we already know that each and every neuron is connected with each other and there is a weight assigned to it. Now, how weights are initialized when it comes to practicals, you will understand how weights are initialized, how weights are changed, but I'll just give you an example so that we understand more. Okay, so if I talk about H1, we already know H1 is nothing but weights into inputs, right? The dot product of weights into inputs. So here H1 is nothing but W1 X1 plus W2 X2. And what is H2? H2 is nothing but W3 X1 plus W4 X2. And we already know that each neuron has a activation function. Now, based on activation functions, the neurons are activated in a neural network. If you want to know more about activation functions, I have separate videos for that. I have talked about step activation function, linear activation function, sigmoid, ReLU, tanh, and a lot more. So let's assume that we have sigmoid activation functions here in each and every layer, just for a simplicity purpose. And we already know that sigmoid function is nothing but 1 by 1 plus e to the power of minus x, right? It always ranges from 0 to 1. That we already know. So here my output of H1 will be, I will write it as output of H1 will be 1 by 1 plus e to the power of minus H1. Okay, so H1 is W1 plus W1 X1 plus W2 X2, and this particular thing is passed through an activation function. So my output of H1 will be 1 by 1 plus e to the power of minus H1. Okay. Similarly, my output of H2 will be 1 by 1 plus e to the power of minus H2. Okay. Moving forward, let's take a small example for understanding. Example. Let's say I will define my inputs X1 and X2. Let's say we'll take some arbitrary values 0.05, 0.1, and let's define all our weights. I have W1, W2, W3, W4, W5, W6, W7, and W8. Let's assign some values to it. I'm just arbitrarily populating 0.1, 0.2, let's say 0.1, 0.2, 0.3, 0.3, 0.4, 0.5. Okay, arbitrarily I have populated the values and I have my final y1, y2, the actual values. So I'll name it as T1 and T2. So let's say T1 is 0.01 and T2 is 0.99. And we also know that there is a bias which is being associated, right? The normal formula of a neural networks is nothing but WIXI plus bias, right? So I will also add the bias. So let's say I have B1 and B2. Now what is B1? Let's say it's something like this. We have B1 here and we have B2 here. So bias are associated with a layer, right? Similarly, I will just have B1 and B2 values. Let's say B1 is 0.1 and B2 is 0.1. Just for our simplicity, let's move ahead. Let me just expand it. Okay. So right now, let's do the forward pass. Only when we do the forward pass, then we will know about the backward propagation, right? So forward pass. Let's try to do forward pass. So H1 is equals to W1x1 plus W2x2 plus B1. Now what is W1? 0.1 into 0. What is x1? 0.05 plus 0.2 into 0.1 plus 0.1. So what will be the value? 0.1 into 0.05, 0.005, 0.005 plus 0.02 plus 0.1. So it's something like 0.125, if I'm not wrong. So mathematically, there could be some mistakes while I solve this problem, but the whole idea is to understand how to solve. Okay, mathematical calculations could be ignored in case I'm doing some mistakes. So output of W1, output of H1 will be 1 by 1 plus e to the power of minus H1, right? So this is nothing but 1 by 1 plus e to the power of minus 0.125. So what is that? We'll take help from Google. E to the power of minus 0.125, 0.88. So 1 by 1.88, if I just calculate it, the value will be 1 divided by 1.88, 0.53, 0.53. That's the value of the output of H1. So why we are calculating the output of H1? Because the value of H1 goes into the next layer. If we have multiple hidden layers, let's say this is just one hidden layer here, right? If I have multiple hidden layers, so the output of H1 goes into the next hidden layer and it goes on. So this entire technique is known as forward pass, right? Because we are moving in the forward direction. So output of H1 is calculated. Similarly, we will also calculate H2. H2 is nothing but, let's see the formula, W3x1 plus W4x2 plus B2, right? Sorry, B1. B1 is associated with first hidden layer, B1. So W3x1 plus W4x2 plus B1. What will be the value? W3 is 0.1 multiplied with 0.05 plus W4 is 0.2 into 0.1 plus 0.1. It's same, 0.125, and the output of H2 is equals to, it's going to be the same value, right? 0.53. So let's save these values. After that, what we will do is, now we'll calculate for Y1. We will move it to the next step, right? So what is Y1? Let me just zoom out so that you check everything. In case the video is bit fast, you can just pause and take a look at it. Okay. So I'll just expand it. Okay. Now let's calculate for Y1. So what will be the value of Y1? Y1 is equals to, similarly, WIXI will take the same funda. What is, this will be W5. What is XI? XI means the input. So input to W1 is the output of H1, right? So W5 into output of H1 plus W6 into output of H2. W6 into output of H2 plus by S2. Okay, so what will be the value? What is W5? W5 is 0.3. 0.3 multiplied with output of H1 is 0.53. 0.53 plus what is W6? W6 is 0.3 again. So 0.3 into 0.53 by S is 0.1. So the final value will be, let's calculate, 0.3 into 0.53, this much. I'm just doing into 2 because it's two values, plus 0.1. So 0.418, if I'm not wrong, 0.418. That's the Y1 value. So what will be the output of Y1? In the output layer also, we also have the sigmoid function. So that will be 1 by 1 plus e to the power of minus x. So minus x nothing but minus y1. So 1 by 1 plus e to the power of minus 0.418. So we'll take the help again. 418. 0.65. So we'll do 1 divided by 1.65. That is coming as 0.6. Okay. So the output of Y1 is 0.6. Similarly, we'll also calculate for Y2. So what is Y2? Let's look at the diagram. Y2 is nothing but W7 multiplied with output of H1 plus W8 multiplied with output of H2. Okay, I'll just write it down. W7 output of H1 plus W8 output of H2 plus B2. So what is W7? W7 is 0.4, this is 0.5. So 0.4 into plus 0.5 into plus 0.1. So what is output of H1? 0.53, right? 0.53. 0.53 into 0.53 plus 0.1. What will be the output? Let's calculate. 0.4 multiplied with 0.53, 0.218, sorry, 0.212 plus 0.5 multiplied with 0.53, 0.265 plus 0.212 plus 0.1, 0.577. I'm just cutting it. 0.577. Okay. So what will be the output of Y2? 1 by 1 plus e to the power of minus 0.577. So this value will be, let's calculate, 0.577. 0.56. So 1 divided by 1.56. It's nothing but 0.08. Okay. So the output of Y1 is, sorry, output of Y2 is, should be some mistake once again. Okay, my bad. What is the value? 1 divided by 1.56. Oh. 1 divided by 1.56. 0.64. So output 2 is equals to 0.64. So now I have output 1 as 0.6 and output Y2 as 0.64. So once we get the output values, that means I got the Y hat values. That means what is the predicted output that we got? We already have the actual values, right? What are the actual values? 0.1 and 0.99. So our next step is going to be calculating the error. So how to calculate the error? We already know the basic cost function is nothing but summation of half y hat minus y square, right? So we'll use the same technique. We'll do half y1 minus y hat. What will be the y hat? Output of y1 square plus half actual y2 minus output of y2. So this is actual y2. I'll just name it as t2 so that we don't confuse. So you do it t1 minus this or this minus this, it's going to be same because ultimately we are taking a square of it, right? So this will be half of 0.01 minus 0.6 square plus half 0.99 minus 0.64 square. So what will be the value? 0.01 minus 0.6, sorry, 0.6, 0.59 into 0.59 divided by 2. What is the value? 0.17, 0.17 plus 0.99 minus 0.64, 0.35 multiplied with 0.35 divided by 2, 0.06. 0.06. So what will be the final value? 0.23. So that is the error which we got. 0.23. Again, I'm telling, if there is a minor mistake in the calculation, just ignore it. Okay. Just try to understand the flow. So once we get the errors, that's where the backpropagation step happens. So just giving a brief idea about backpropagation, how it works. So in neural networks, initially the flow goes on like this, from left to right. The inputs are traversed through hidden layers and it goes to the output. Once we get the predicted output for the first iteration, then we calculate the cost function. Based on the cost function, if the cost function is very high, that means the error is high. That means we backpropagate through the neural networks and we change the weights. We change each of them. Everything happens when it comes to the practical codes. When you start implementing the models in ANN or CNN, you will not understand how the weights are updated internally, but this is how the mathematics is backend. Okay, how the mathematics behind the neural networks work. So once the cost function is done, then the next step is we backpropagate, and while backpropagating, the weights are changed. Our main ultimate goal is to reduce the cost function, right? So let's start with the, now we backpropagate. Okay, just ignore my handwriting. So backpropagation is nothing but to update the weights. So let's find the error at W5. Okay, we'll find the error at W5, this one. This particular, what is the error? We'll try to find that. So what is the error at W5? It is nothing but, if I take a derivative of it, derivative of E total with respect to 5, we'll have to find the error, right? So what is E total? E total is nothing but the cost function. I'll just name it as E total, the total error. Okay. E total is equals to 0.23. So what is the derivative of E total with respect to W5? Now here in the function, in the formula, we don't have W5, right? So if we take a derivative of W5, it will not be able to do it. So here we will have to use the chain rule of backpropagation. We'll apply the chain rule. What is chain rule in depth? I will cover it in the next class, but try to understand this way. So delta of E total divided by delta of W5 is nothing but derivative of, so it's not delta, it's derivative, my bad. So derivative of E total with respect to out the Y1 multiplied with derivative of out Y1 with respect to Y1 with respect to W5. So if you cancel out this with this, this with this, ultimately we achieve the target, right? So we can use this instead of this, we can use this. So this is nothing but the chain rule. Okay. Now individually we'll try to calculate these. So I'm just not expanding, I'm just calculating here. So delta of E total with respect to, sorry, again I'm telling delta again and again. So derivative of E total with respect to out Y1. So what is it? I will just name it like this, out Y1. What is E total? Half of T1 minus, sorry, let me redo it so that we understand properly. T1 minus output of y1 square plus half of T2 minus output of y2 square. Square. Okay. So we don't have the output of y1 here, right? So the derivative of this will be 0, as we already know, because it's a constant. So we'll only consider this particular part. So here the final outcome is going to be 2 into half of T1 minus output of y1, 2 minus 1, multiplied with minus 1 plus 0. Okay, just try to understand with respect to x, because only when you write down output of y1 instead of x, then you will understand what is the formula. Okay, so if it cancels down, minus of T1 minus output of y1 is nothing but, what is T1? We know that it is 0.01 minus 0.6. If I remember, output of y1 was 0.6. So what is this value? This is 0.59. So this first thing we got it, 0.59. So let's find the second thing. What is derivative of y out of y1 with respect to y1? What is output of y1? Go back to the activation function part. Output of y1 is nothing but 1 by 1 plus e to the power of minus y1. So derivative of y1 with respect to 1 by 1 plus e to the power of minus y1. What will be the output? The output is going to be output of y1 multiplied with 1 minus output of y1. 0.6, 1 minus 0.6, which is nothing but 0.6 into 0.4, which is 0.24. Okay, let me just expand it further. Okay, so our next step is going to be the third part, derivative of y1 with respect to w5. What is y1? Let's go back to the formula again. Y1 is this whole part. So with respect to w5, so I'm not writing all these things because these are constant, right? For w5 it's going to be constant. So let me just write it down first. W5 of y1 is nothing but w5 into output of h1 plus w6 output h2 output h2 plus b2. These are constant, right? So I'm just cancelling it out. So d by dw5 with respect to w5 into something. So we already know that derivative of, let's say 5x is nothing but 5, right? Similarly, this output will be out h1. So what is output of h1? Output of h1 is 0.53. So here I'm writing it as 0.53. So what will be my total formula? E total with respect to W5 is nothing but 0.59 into 0.24 into 0.53. So 0.59, sorry, at 0.59 multiplied with 0.24 multiplied with 0.53, 0.07, 0.07. So this is the error with respect to W5. Similarly, we have to calculate the error with respect to all the weights. Now, once we have already calculated the error with respect to with respect to W5, what will be calculating? So let me write it down. It's calculating the new W5. I told you, right? When we backpropagate, we change the weights. So I will name the new W5 as W5 new is nothing but W5 minus eta of error of total with respect to W5. I think we have already learned about this particular formula. Now you can relate it. So what was my W5? If you go back to the example again, my W5 was 0.3. So in the first run, my W5 was 0.3 minus eta of dE total by dW5. So which is nothing but 0.07. So this is my learning rate. Learning rate. If I define it as 1 or else 0.5, up to you. Let's define it as 1. So 0.3 minus 0.07. So what is the final value? 0.23. So this is the new weight of W5. So the old weight was 0.3. Now the new weight is 0.23. Similarly, this entire process goes on for all the weights. And this is how you backpropagate and change weights throughout the system. This is how it works. When it comes to practicals, it's going to be very straightforward. It's going to be very easy for us to implement, but this is all the mathematics behind it. Instead of sigmoid function, if you are using some other function, ReLU or something, you have to do the necessary changes accordingly and then do the calculations. So that's it from my side. I hope you understood backpropagation in neural networks. I tried to explain it as easier as it could be. Thanks for watching, guys. And our next video will be on chain rule, and then we'll talk about vanishing gradient and exploding gradient problems. If you like the video, please like, share, and subscribe among friends. Thank you.